Why do some developers, myself included, love to work with clean architecture while other developers despise it? I'll try to answer this as part of this video while we look at a practical example of what we have to do to introduce a new feature to an application that's using clean architecture. Clean architecture is one architectural approach of how you could structure your application. It consists of the application core, which typically contains the domain and the application projects, and then we have the outside concerns or layers represented with the infrastructure project here and the web API project being the entry point into our system. Now I'll discuss what we get with this type of structure as we go through this video, but let's jump into the practical perspective right away before this becomes too boring. So what I want to do in this video is introduce a new feature for archiving my to-do items. So we have this domain project that contains our domain entities. Now you can implement these as just anemic domain models, something that you're seeing right here, with properties that have getters and setters. And what we would need to do to implement support for archiving is having a flag, let's call it is archived. And then we may also want to track when this occurred. So let's use a date time, and I'm going to call this property archived at. So this is our first touch point for this feature. We update our domain entity, and you're going to see as we go along and implement this functionality, how we are going to traverse through all of the projects in the clean architecture, the domain application infrastructure and web API projects. And this has both some benefits and some drawbacks. One more thing I'd like to add here is a domain event for when a to-do item is archived. So I'll say create a new class. I'll actually make it into a record, but doesn't matter. And let's call this to-do item archived domain event. So as I said, I'll move this into a positional record with the only argument being the to-do item ID, or rather the only property, and I also have to implement the iDomain event interface. So these are my two touch points in the domain project. And we've added one new file and updated an existing file. So now we can move one level up, which is the application project that contains the application use cases. These basically represent your application's features, and from this layer you are allowed to reference the domain and its entities and domain events in this example to orchestrate them and implement some behavior. So how we're going to approach this is create a new feature folder, let's call it archive, and this is going to contain my files for this new functionality. So one thing I need is an archive to-do command. Let me go ahead and create this, and I'll use a similar approach here with a record with the argument being a to-do item ID, and I have to implement iCommand. Now these are my own abstractions that allow me to easily implement CQRS, and then after I have my command, I need another component to represent the handler. So this is going to be the archive to do command handler. Now here I have to similarly implement the iCommand handler interface where I specify my command type, and then I have the handle method that contains my actual logic. So here it's pretty common that we would need some sort of dependencies to implement this, and how clean architecture implements this is by exposing abstractions. This allows you to be coupled to the interface and not the concrete implementation. This also improves testability. If you want to do unit testing, you can easily mock these dependencies to test out your behavior. So let's inject a database context. I will also need an iDateTime provider. This is my abstraction for getting the current time. And I'll need an iUser context so that I can access the information of who the currently authenticated user is. So then I can proceed with my implementation, and for example, I can fetch a to-do item from the database, making sure that the to-do item ID matches the one in the command, and the respective user identifier is the same one as on the user context. That is, we are trying to archive a to-do item that belongs to the currently authenticated user. Now, if the to-do item is null, then we can go ahead and return, for example, results, failure, and then I have our respective abstraction in my domain project. It contains some errors, and in this case, I want to say that this to-do item was not found. Now, there's also another point here. What if the to-do item is already archived? We can check this by examining the isArchived flag. And for example, this could also be a failure. So let's say results and then failure. And here I would need to touch the to-do item errors class to introduce another error, let's say already archived. So going back to my handler, I can now say to-do item errors already archived, and we can pass in the to-do item ID. So after these preconditions, we can finally go ahead and do something, which is set the isArchive flag to true. We can set when it was archived by using the datetime provider. I can say datetime provider UTC now, and then I would want to say await context save changes async. Now another thing we could do here is raise a domain event. So this is going to be a new to-do item archived domain event, and we want to use the same ID as our to-do item. Finally, we can return results, success, and complete our handler. So if anyone's keeping track, we have touched two projects so far, the domain and the application project, and we've updated one file, we made 1, 2, 3 new files, and updated another file. So we have 2 updates and 3 new files, and we're not done yet. So the next thing we need is to check out our infrastructure project. Here we have configurations for our EF core entity, and here you can consider if you want to add some configurations for your new properties, which are our flag and the datetime property that we created. Then the next thing you need is to create an EF core migration, and I'm going to go ahead and do that. So I'll say add migration, give my migration a name, and then I'm going to specify the output folder for my new migration. This migration file is now going to contain our 2 new columns, the isArchived and archived add columns. And when we start this, it's going to be applied automatically because that's the setup I currently have, and we'll be able to persist these columns in the database. So this is already the 6th new file, although it's auto-generated, but you still need to create it for this feature to function. And then one final thing we need to be able to expose this to the outside world is an endpoint, and we have these in the web API project. Let me drop this down, and here we would need a new class called an archive endpoint, and the convention that the other endpoints implement is implementing the iEndpoint interface where we can map the respective endpoint. So I'm going to just use what we already had in the complete feature. I'll make this internal and sealed, and then let's update this to be archive in the route. I need to use a different command, the archive to do command. This is going to resolve automatically the respective handler from dependency injection, and then I'll be able to return the results of this to my API caller. So this wraps up our new feature that I can now deploy and make available to my users. Now, a couple of more touch points would be updating the existing functionality. For example, in our query to fetch the to-dos, we would probably want to filter out any to-dos that are not archived. So I can say not to-do item is archived, or we could optionally create a filter to choose if we want to return archived items or not. I'm going to leave this like this, and let's count the number of updated or created files. So we have our endpoint, our auto-generated migration. We didn't do anything with the config file, so I'll close that. We have an update in the errors class, a new command handler, a new command, a new domain event, and an update in the domain entity. And we also had to navigate through all of the layers in the solution. So we had to touch the domain project, the application project, the infrastructure project, and the web API project. And we also needed to know where in these projects to place the respective files. Now, it's helpful that there is at least some sort of convention. For example, you can notice that everything that relates to to-do items is nested under a to-dos folder. So we have endpoints and then to-dos. In infrastructure, we have to-dos as a base folder. In domain, we have to-dos. And then in the application folder, we also have to-dos and all of the respective features for the to-do items. So the drawback is definitely that you have to touch a lot of projects and potentially create a bunch of new files to implement a new feature. The benefit, at least as I see it, is you get a clearly defined structure of where things should go. Now, depending on what level of experience your team has and how comfortable they are building complex systems, this may be either an advantage or it could be slowing you down. So when we talk about clean architecture and whether it is the best or perhaps not, we also need to consider it from the context of which team will be implementing it. One benefit that I can highlight here is look at this command handler. It doesn't really know who will be calling it, or rather who's going to be sending out the command. In the current implementation, we are invoking the command from our API endpoint, but there's nothing to stop us to run this from some scheduled background job. where I can, for example, pick up any to-do items that you haven't completed in, let's say, 30 days, and I can automatically archive them. Additionally, I can also trigger this use case from a message queue, and that's all because I've abstracted the input layer that triggers the command from the actual logic that executes it, which is encapsulated in my command handler. Now, if we're talking about pure clean architecture, we wouldn't even want to have a dependency on EF Core. That's something I'm willing to accept as a trade-off because I believe it allows me to go faster if I can reference EF Core directly, and the chances of me having to switch away from EF Core, or to be more precise, from a SQL database where I'm using EF Core on top of it, are pretty low, and this is a trade-off that I'm willing to accept. If my constraints were different, then we could talk about adding repositories here, but that's only going to slow you down considerably more, and we would potentially have to touch more files than we already did to implement this functionality. And one last thing before I wrap up this discussion is that with clean architecture, you get a clear direction of dependencies that you want to enforce inside of your solution. So at the bottom, or rather at the core of the system, we have our domain project. It's supposed to contain our main business entities and any related logic, and it's not supposed to depend on anything else. This is where you have your so-called enterprise business rules. In order to make this independent from anything else, we define it in its own project. And then we control which projects are allowed to reference it. So the domain project should not reference anything else, which allows us to place it at the core. Then we have the application project, one level above, that's allowed to reference the domain project and interact with the entities inside, but it shouldn't know anything about the infrastructure details, like which database we're using, how the datetime provider works, how we get the user context. So we hide those behind abstractions, or in C# these are just interfaces. I already mentioned how this lets you have more testable command handlers, but I still recommend using integration testing with something like test containers to get more quality test cases than just testing your handlers with mocks. And then on the outsides of this architecture, we have the infrastructure and the web API projects, which we consider as implementation details, although it's not really as simple as that. For example, the web API also acts as a configuration route where we define our application services and wire up everything that's needed to serve traffic from our API. But when you think about it, the application layer really doesn't need to know anything about this to be able to deliver business value to your users. Of course, you can achieve all of this using something like vertical slices, where you're basically going to merge together the projects that I have here into one highly cohesive feature slice. You're going to have less projects to navigate through, and all of the components for a single slice are typically going to be inside of one folder. Now, this is great for teams that know what they are doing and what they want to achieve, and they can also enforce the same direction of dependencies as we have here. However, they have to do it purposefully. Whereas with something like clean architecture, the design itself and the way the projects are structured forces you to apply these same rules. So that's just something to ponder if you're considering which architectural approach to take. Let me know in the comments what you think about this. Near the end of this video, I briefly touched on vertical slice architecture, and if you want to learn how you can implement this from scratch in .NET, then I recommend that you watch this video next. Make sure to smash the like button on your way out. Thanks a lot for watching, and until next time, stay awesome.